Hello everyone, welcome back for another lesson. In this lesson, we will be talking about kinetic energy. So it's pretty simple. What is kinetic energy? It's the energy that's involved when an object is in motion. So anything that's moving, whether it's a person or it's an object, well, it requires energy to move. So that energy, we call it kinetic energy. Now, how do we calculate this? So let's go straight to the point. You have the equation here. So EK for kinetic energy is equal to half times the mass of the object times its velocity, so V is for velocity or speed, squared. The kinetic energy is in joules. The mass of the object is not in grams, but it is in kilograms. And you will find that masses, when it comes to physics-related topics, so this is related to physics, when the mass is involved in an equation that is physics-related, we express it in kilograms. When the mass is related to a chemistry type topic, we express it in grams. So every time you're going to touch upon a physics topic, the mass will always be in kilograms. Next, we have the velocity or speed of the object, which is in meters per second. Okay? So first example, what is the kinetic energy of a 45 kilogram object moving at 13 meter per second? So the first example is pretty straightforward. So we're just going to replace in this equation. So we have a 45 kilogram mass and a 13 meter per second speed. Let's not forget to square it. So what do we get? We get the following, right? So 1/2 times 45 times 13 squared. Now, one thing I want to point out, if we do significant figures, this is not a measurement. Okay, so the half is not a measurement, the 45 kilos is, and the 13 meter per second is. So the answer should have, because of these two numbers, it should have two significant figures. So this is, let me delete this. This is what you get. So you get this amount in joules, but we need to keep only two significant figures, so we are forced to use scientific notation. So after we convert, we get this, or the easier way is to convert this amount of joules into an amount of kilojoules. So by dividing by 1,000, we get 3.8 kilojoules. So probably most of you will find it easier to not use scientific notation, but just express your energy in kilojoules. So that's the first type of example. That's the easiest one, the most straightforward one. Let's take a look at a second one. The kinetic energy of a boat is calculated at 52,000 joules. So the boat has 52,000 joules of kinetic energy. If the boat has a mass of 39,000 kilograms, with what velocity is it moving? So what's its speed, in other words? So if we replace, what do we get? We get the following. So 52,000 joules is equal to 1/2 times 39,000 kilograms times the velocity squared. So if we multiply this and bring it over to the other side, we're going to get something equal to v squared. If we want to solve for v, we have to remember to square root both sides. Okay, so it's important when you're solving for the speed, because the speed is squared, you don't want to find v squared, you want to find v, just velocity, just speed. So you have to square root both sides to get your final answer. And your final answer is 1.63 meters per second. Now, clearly you'll notice here that I did not do significant figures here. So you have, it depends on how the number is expressed. Here there should have been a dot, let's say, to show that it's precise. So this would have been 5 significant figures, 5 significant figures if there's a dot. Or if we say no, there's no dot, so this is not exactly precise, we would have had to say it has 2 sig figs and 2 sig figs. So regardless, my answer has 3. It has neither 5 nor 2. Obviously, I did not follow sig figs. Okay, so but it was just to explain in case you're wondering. So the answer, 1.63 meter per second. So that's the answer for that one. Next, we have more theoretical questions. So it could happen that you would be asked, what would happen to the energy if we double the mass? So in this case, we don't need to work with numbers, although we could, but we don't need to. We can work just in theory. So if we take a look at this, now what changes? This does not change, and the velocity doesn't change. The only thing that we're really changing is the mass. So in theory, if we want to analyze this, we can pretend that this is no longer there because it is constant. This is also constant. We're not touching it. So what is really changing? It's the mass. We are doubling it. So what do we end up with? If we want the two sides to be even, we have to, what that implies, that the energy would be doubled. If I double the mass, I double the energy if everything else stays equal. Okay, so in other words, 2ek is equal to 2 times the mass if the velocity stays the same, and that half obviously is always there in the equation. Okay. Next, what would happen if I double the velocity? So what happens to the energy? So this we're not taking it into consideration. This we're not taking it into consideration. But we will double the velocity. Now, don't forget the velocity is squared. So basically what we have is this is equal to how many times the original energy? Well, 2 to the power of 2 is 4. So that means my energy will change by a factor of 4. It'll be quadrupled. Okay? Because we're doubling the velocity, but the velocity is squared. 2 squared is 4. So these are your typical problems for kinetic energy. It is not more complicated than that. And if you have questions, you know what to do. Otherwise, in the next lesson, I will talk about potential energy. But until then, take care.